Coming up on the FRC Open Alliance show, 5,000 Hammerheads is back, and wow, their progress is absolutely phenomenal. We're going to get a robot demo of what their current progress is, and it's really come together overall. So you'll see the intake, you'll see how what's called their Dye-Rotor works, one of the coolest mechs I've seen in Rebuilt so far, as it goes through their turn us up. And then we're going to be also, in the beginning, looking more at their fuel simulation demos they've been working on, and also their autonomous planner that they call Shark Planner as well, too. So a lot of great stuff to go through. This is seriously one of the coolest robots I've seen so far, so we hope you learn a lot in this here on the FRC Open Alliance show. This video on fun is brought to you by our viewers, supporters, members, and also in partnership with the following. For over 100 years, Kettering University has offered a better education because from day one, that education has been built on hands-on, co-op learning. Kettering's impressive alumni network includes founders, presidents, CEOs, and frontrunners who have a reputation for transforming industries with their resolute leadership. Apply today at kettering.edu/first. Founded by First alumni, FRC Tees understands what teams need. High-quality apparel fast. From t-shirts to jackets and more, with a free 14-day turnaround and faster options available, you can join 200-plus teams who are already saving. Get a free quote by scanning the QR code or going to frctees.com. Let's welcome back onto the FRC Open Alliance show. It's 5,000 Hammerheads, once again from Massachusetts. So good to see you all. We had you back a few weeks ago and had some awesome progress in. We got a lot of great stuff to go through today. So if you don't mind, just reintroduce yourselves and let's hop into all the awesome progress your team's been working on.
So I'm Tori, I'm the code captain.
And my name's Logan, and I'm the build and CAD captain.
So we've been working on, obviously, a lot of stuff. I'll start with the code that we've been working on. One big thing is dual sim, which a lot of people have heard about. It's gotten a lot of traction, I'd say. And that was pretty much right after our last interview, I think. I created this relatively basic fuel simulation program that would just simulate all the collisions of the fuel with the field and the hub and everything. Basically is a kind of simpler alternative to MapleSim, which is both and is really great, and also it has a lot of things like it has the whole simulates the physics of swerve and all that stuff that not necessarily everyone wants, as well as I think there's a little bit of issues with that being like having contributors and support right now. So I made that and posted it, and I've got a lot of great feedback and responses, and as well there have been some people who've also helped contribute to the project with I think someone added spatial partitioning to make all the collisions run faster, and a couple other small things. So I'm really grateful to everyone who's been helping out with that, and I'm really happy with where we are. I think it's really helpful for testing on autos and such, because you can see roughly, it's not one-to-one with reality obviously, but roughly how fuel will behave in your auto, how like it's going to be scattered about, and whether you'll actually be collecting much of that, as well as just kind of driver practice in sim I've found to be actually pretty helpful with learning kind of how to see the fuel just from the little advantage scope window and all of that. So yeah, we got that working, and then I pretty much wrote the basics of the entire robot code at this point. I guess some elements I want to highlight are I have this auto align feature going through the trench and the bump. So when we're going through the trench, it will automatically align the robot to point in like this direction, so the intakes are going through, so they won't hit the sides. And it will also adjust the Y translation, so we're not hitting the edges. And hopefully that should let us be able to pretty much full send it through the trench and not have to worry about going slow and careful, which will hopefully increase our cycle times a lot. We'll see how well that actually works out once we have a trench. And then over the bump, it doesn't do the side-to-side translation, but it does do the alignment diagonally, because as we've seen from like Robot 3 Days teams and everyone else, when you're going diagonally over the bump, you're less likely to get beached in the center of your robot and all of that stuff. So I tested that out in sim. It was working pretty well, and I also got passing set up, all of that. I'm pretty happy with. So then I guess the last thing I want to highlight, which I did over this weekend, just recently, is this configurable auto setup, where thought through it a bit and wanted to build on what we did last year. Last year we had basically you entered a string into the dashboard that would say what auto you're doing as like a combination of paths. And the thing is, this year there are a lot more types of paths, a bit more of a complicated auto instead of just what branch you're going to and such. So I created our own little GUI. I'm calling it Shark Planner, though it's not like a real program that other teams will be able to just plug and play, use like Path Planner or whatever. It's just for us, really. But maybe some other teams could find some use out of inspiration from that. And it will, you can select the paths that you want to do, and it will chain them together, as well as give you timestamps for all of the stuff. We were kind of going back and forth between what path planning software we wanted to use, Path Planner, Beeline, just like great drive to point stuff. And we ended up with Path Planner because it has the timed autos as opposed to the more positional autos of Beeline. That's because when there's going to be a lot more coordination in auto, I think, and being able to know where you are when is really important for coordinating with your alliance partners and making sure you're not running into them, as well as at the end going to climbs, you know that you will have the time, or at least that your robot will try and have the time to climb. So that's why we are using Path Planner, and it will chain those paths together. It will tell you when you are going to be where. And it will, like, you can set this up on the field. You don't have to like deploy the code or anything. And I know Path Planner does have the hot reload feature, but I found it works sometimes, doesn't work sometimes. And I just wanted to make sure that this would always work and also be more customizable for options of maybe we want to be passing in this one, and instead we want to be just collecting our hopper and doing cycles and whatever. So I'm pretty happy with that, how that turned out, and how much I was able to get done in such little time here.
Yeah, and I know you said that the Shark Planner might not be something that's disseminated amongst teams necessarily. The field simulation demo that you showed, is that something like other teams can pick up and start using? Is it like just a fork off of something else that's been out there?
It's I mean, it's pretty much completely from scratch, but it is 100% something other teams can use, and something I've seen a lot of teams using themselves. It is currently just pretty much copy and paste the file in. I'm going to try and hopefully soon set it up to be an actual kind of vendor dependency that you can install. But I tried to make it as simple as possible, require like the least code setup possible. So teams wouldn't have to structure their code around it in the way that maybe MapleSim would require a little more of. And I've definitely seen quite a few teams using it, which I'm happy with.
Awesome. I'm glad to hear. I'm glad other teams are adopting it as well too, and getting great usage out of it. That's awesome. So, can we let's start to move on some of your physical bot progress for it. Watching your build blogs that we saw in there, we definitely have some assembly coming together for it. So, what do you want to run through first?
All right. So this is our robot. This is Icarus, named, I'd say hopefully not accurately, but we'll see. We'll start off with our intake here. So hold on, let me preface everything in saying this entire bot was assembled over the past day and a half, 2 days. So we haven't had much time to test it. In fact, we tested this for the first time about 5 minutes before we started filming.
The full system.
So no promises on anything working, but that's what we're here for. So here we got our intake. It's on its own rack and pinion system, and it's geared with two separate motors on each side. At least on this side. On the other side, they're going to be linked through a hex shaft, or not through a hex shaft. They'll actually be a carbon fiber tube that'll be linking it, but that's not ready yet. those slide in and out, and they're also made out of SRPP. What I did actually was for the wires for this motor in here, the wires are actually glued inside of the rack itself. So that keeps them protected from external impacts and stuff like that. And this will end up getting a sleeve put on it and obviously a proper termination. But, you know, we're all in prototyping stage right now. Or actually not. But next we'll move so once that pops up and in, we go over to our Dye-Rotor here. This has been I'd say the star of the show lately, where it spins around and then also feeds in the balls and they get fed up into the turret. Something that's unique about our Dye-Rotor is that we're actually triggering it coaxially, which means that we have 2 separate motors, one on each side. This motor here just affects the rotation of the wheels. And then this motor over here just affects the spin. So in doing that, we're able to tune it basically to perfection, the way we want it, and have both the wheel speed and the hook speed be spinning at optimal rates, depending on each other's speeds, to be able to feed it up at the rate we want.
As well as what we found that can be helpful is having a little bit of kickback at the start, where we run both in reverse and then wait for the feed motor to get up to speed before starting the hook, so that we make sure we clear all the fuel that's currently in the hook. And that wouldn't be possible without it being coaxial.
If you watch our latest video that we posted on, I believe it's 2.2, it displays it in slow motion, that little kickback, where it goes backwards and then it kicks it forwards. And then from there, we move upwards to our turret. This here, we're aiming for 720 degrees of rotation. So in doing that, we have to manage a lot of cable. And you might be asking us how. That's a great question. We're still figuring that one out. But we got a week and a half till week 0, so we'll get there.
We have this.
Yeah. Okay. Something that we did attempt to do was put some polycarbonate between basically inside the sleeve to have it coil up in the way that we'd like. It didn't work out so well for the turret mechanism. However, what it did work out well for was our intake. So this intake rack here has 2 pieces of, I believe, 1/32 inch polycarb sandwiched on either side. They're long strips. And what that does is it keeps it relatively in line, sort of similar to how a cable chain would work, while also giving us the benefit of being light and also easy to like work with and everything. So you see, as I move the rack in, it just kind of stays in line, which is what you want to see to keep it, like it'll flop down if I do that because I need to fix it better apparently. But the general premise of it seems to work pretty well for a few wires. Back to the turret. With our turret, what we're also doing is you'll see on our plate right here, we have a bunch of holes. These are going to be filled in with a bunch of belts, giving us a 2-to-1 rotation for our encoder. So for every single 2 rotations of our turret, the hex encoder, which is just set in right here, will rotate once. So what that does is allows us to have the absolute, no, actually Tori can talk more to it if you want to.
Yeah. So I mean, you know, obviously there's a big consideration with a lot of teams are doing hard stops. A lot of teams are doing the Chinese remainder theorem. And what we kind of decided on is both the Chinese remainder theorem, we want an absolute position. We don't want it to be dependent on when you're deploying the code and everything. Even if we could have like a set 0 at the start of a match, just for development and everything, when you're redeploying code constantly, it is not ideal to have to re-zero the turret every time. So we want an absolute position. And both CRT and just an absolute encoder allow us to do that. I think there's a couple of reasons why we went with just the absolute encoder. For one, it's just one less device, which can be like simplicity-wise better. And then also, I think it takes up less space. Is actually
It doesn't necessarily take up less space, but what it does is I think the biggest thing for me was having an absolute position of it no matter where it is inside of its rotation cycle. The Chinese remainder theorem, what it does is it would require me to add more. It would require me to add encoder further outwards rather than inwards, at least in a practical sense. So by doing this, I was able to at least keep it pretty narrow, giving us room for balls on each side. So this does take up technically more space, but it takes up, I guess, less width, which is good because that's where our balls are or fuel is supposed to be stored.
Just with how that worked out. But also there are some edge cases with the Chinese remainder theorem. I'll be honest, I don't know the details of exactly what happens in those, but I know that there can be some weird situations where the math can be ambiguous, and that's just not ideal for things in general. Obviously, teams are working around it, and people can use it. But for us, I think this is what works out well. Gives us a simple solution, I'd say, without having to worry about setting that all up, allowing us to focus on maybe some other aspects of the robot.
And before I get on to the physical shooting and hood mechanism, I'd like to touch on our side plates and our climber. So currently we don't have our climbing hooks installed yet. Those have been put on the those have been, I don't know, like set aside for right now while we focus on getting the rest of the robot ready. Those are gonna be fairly easy to install. The motor's already installed down here. It's just putting in the hooks. I have to cut them out. Honestly, probably wouldn't take me too long. But anyway, these slides here are designed such that a bearing will be able to ride inside of it, and the hooks will come out. We've had videos posted about it. That was mentioned on Fun before. If you watch our last video, we discussed it a little bit more. This allows us for a single constant action because it's just one motor that winches it out to the right height. And I know that there are actually a few teams who are planning on using a similar design to this, which is, I'd say it's pretty cool that we were able to inspire some teams with this. Another thing are the side plates. These are 1/4-inch aluminum side plates that were powder coated by Mechanical Advantage. We are very, very grateful for their time. We were able to go there on Saturday and get those things beautifully powder coated. And, I'm very excited about these. It was very nice of them to be able to lend their time and let us use their powder coating setup. The other thing about these are also our frame rails. Well, for two sides, we have 2x1 on the front and back, or actually just left and right, and then on our front and back we have basically it'll end up being 3/4 inches of aluminum sandwiched between each other, but it goes a 1/4-inch rail, and then we got these plates, and then it'll be another 1/4-inch rail to give us the same structural integrity while also actually taking up a bit less space and giving us more room for mounting stuff, which allowed us to keep everything super low. A big priority for us was having this bowl be at the same height as our bumpers, that we wouldn't have to carry the balls even higher up. So by doing that, we were able to fit everything nice and tightly packed around. So back to our hood. We talked a bit about this on our last interview, so I won't go over it too much. But basically, since then, what we've done is we figured out our optimal gearing ratio. So we're gearing the back wheel a 4-to-1 gear ratio. And
meaning that the back wheel is running like 4 times slower than these front wheels, so we can get that backspin that we want.
So, but what I did though was use the gearing like this, where on the front we use a super large gear and a small gear instead of using a belt to do the gear ratio. That way, in case if we wanted to, we could swap these gears out for a different gearing ratio, just to give us a little bit of flexibility without having to redesign the parts. Another thing that we're doing is gearing to our flywheels. So by doing this, our flywheels will be spinning about 2.5 times as fast as our inertia flywheels will be spinning about 2.5 times as fast as our shoot wheels. So what that does is Tori can go more into the math on that, but it basically makes us go shoot, 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 which is good. So, yeah, and then I'll let you talk more about that, and then I'll get to the hood.
Yeah, I mean, just angular kinetic energy is proportional to velocity squared, And so by doing 2.5 times around the speed, then that's why can't I? It's more. It's more.
Shots per second.
Yeah.
The recovery time's a lot less because it's able to keep that momentum.
Technically, the recovery time is not
Oh.
affected. What is affected is just our drop in RPM is less by doing that, and we don't have to have as big flywheels, which would take up more weight and more space. So we found that this is working out well, should work out well for us.
And one last thing before we get to our demo, is our hood. So something about this turret is we had to keep it super, super small to be able to keep underneath our 22-inch height. I think actually we're at like 21.875 because I don't want to be caught getting clotheslined. This plate here we had to flip around. That'll be cut. Don't worry about that. We're getting there. So anyway, in order to do that, we had to sandwich everything and make it real compact. So this turret's actually only about 6 inches high, or the hood itself. So in doing that, it made it look, I'd say, interesting. There's been a lot of assumptions. I say it looks like a dog or a duck. People say it looks like cars.
I think it looks like the Tron motorcycles.
But from that, we still get our full 14-degree shot height from here, all the way up to 45 degrees. So this pops right up. If we decide to go underneath the trench with this up, which code will prevent us from doing, we will decapitate ourselves. But
You won't do that.
we'll have code that'll automatically lower the hood as we go underneath the trench and then re-raise it up. We have an X44 controlling our hood motor, or X44 as our hood motor, which is geared, I forget what the exact gearing is, but something like 9 or 10 to 1. And then you also have the rack as well. And then we're also dual driving our flywheels with 2 Krakens to be able to hopefully keep that momentum up and have a faster recovery time than a single motor. All right. So now for the time we've been waiting for, while Tori sets up the demo stuff,
Should be pretty much set up.
I'll just quickly touch on our cameras.
Ladies, look straight.
Yeah, let me touch on the cameras then.
Okay, yeah.
We're gonna have 6 cameras on this. Actually, probably gonna end up having 8 because we're probably. I'm pushing for fuel detection. I think we're gonna need it. We'll see.
We will see at week 0 how necessary fuel object detection is, because that would add more complexity. We want to make sure that we're getting the time we need to driver practice and everything. But if we find that's necessary at week 0, we will add that in.
So on that note, we're running 2 orange pies, 1 on each side. We actually have the mouse right here, on each side for the things, and then we're gonna have 3 cameras. One that'll be facing out. Actually, they're not symmetrical. We're basically targeting our front a bit more, or actually our front a bit more. So we have 3 cameras, 1, 2, 3 on each side, and they're all slightly angled slightly differently, with a 70-degree FOV camera right here, and then 110-degree FOV cameras for the other 5. And from that, we're able to get full 360 vision of everything because we are also designed to be able to shoot from any angle. So we're going to need to have that, but also still targeting a front side for best vision.
And I know that some teams are doing a camera on the turret. A couple reasons we didn't want to do that. For one, it can get blocked by fuel shooting, is not ideal. It would also just be another cable going to the turret. It would require some more code complexity with updating the position of the camera constantly, and also like adjusting for all the noise that's generated by the turret, and also the fact that when we're shooting while moving, the turret is not actually facing directly at the hub, and so our vision might just get cut off anyway. So instead, we opted for the 360-degree vision to cover always seeing the hub while not needing to deal with all that stuff. But for some teams, that is the way that they're doing it, and it's working well for them. So.
Cool. On to the test.
We're ready. All right.
Hopefully this goes as we expect. No promises though, but even so, it's FRC and we live and we learn and we try and make things better. So we'll start off by just sweeping the 1 ball up. How about we just do a Dye-Rotor?
All motors are running right now.
Oh, okay.
I'll just enable it. Okay.
You want to up our intake feed?
Sure. Yeah.
See, we tested this out once before this, so we're still trying to learn these things.
Intake is now faster.
9 volts?
10.
10?
Ready?
Yeah.
Hey, Blake.
Something to touch on with our intakes is that, and you can actually see it in the CAD here, we do plan on putting on some funnels. So it's going to have a faceplate here, and then we're also going to end up adding some side plates. So this will also act as an expandable hopper, expanding our hopper capacity.
To be clear, I'm sure people have comments or thoughts about how the dual intakes will work with that. We will be using it as an expandable hopper. I think we touched on this briefly in the last interview as well. At the end of an inactive period or at the end of auto, when we're trying to cycle a bunch of fuel over in the bot, we will just hold one intake out and act as a expandable hopper like most teams are. And then while we're just passing or shooting in our alliance zone, we'll enable both to switch to the direction of motion so that we have the freedom to intake from both sides, and we shouldn't have to worry about fuel getting caught in trying to force the intake in with a bunch of fuel there, because during the time when we're in our alliance zone shooting, we should be pretty empty, just funneling fuel from the ground directly, shooting it.
And so you'll see a lot of that kickback that we were seeing would also be mitigated with that because they'd be going off the hopper walls. Another thing to note is this top roller is geared such that we can power it if we need to. We're still doing testing on that. All these things are just such that we learn them.
We can also, it is fully extended right now. We could make that not fully extended as needed. But currently we don't have control over that.
The very last thing to touch on before I think we end is our bumpers. We're doing something pretty different this year from previous years. We are using welded aluminum as a backer, and welded by the cameraman who had the phone right now.
Koopa.
And what that does is allows us to have, I don't know, in my opinion, I'd say some pretty clean looking bumpers.
And strong.
And really strong. The other thing that I did was I went through with the table saw and I offset the face a little bit on the foam such that it sits actually slightly below the top, which is good because that's how the rules work. So, and what that does is gives us a really, really clean looking bumper while also being very strong and secure. Yeah, I think. Yeah, we mount our bumpers from upside down. I'd say we pioneered the pneumatic bumper mounts. If you look on Chief Delphi, we have some threads on the pneumatic bumper mounts that we used last year. Unfortunately, we are not using those this year because our robot design wouldn't allow for it. But on the contrary, we do have very, very cool looking bumpers in here. So it's a give take. But on that note, I think. Yeah, do you have any questions?
No, I think you all did a fantastic job overviewing this. I absolutely, by the way, love this Dye-Rotor that you have as well. I think it's one of the coolest mechs I've seen so far in Rebuilt. Like, really awesome with that. So, no, thank you so much for that. Obviously, tons to digest. You all have made some incredible progress with this, too. And I know with the Week 0 event coming up soon for you all, I look forward to seeing your bot there as well, too, because I think you're going to be one of the teams that absolutely look out for this year. So, thank you so much for a very comprehensive overview. And we can't wait to see you at the Week 0 event coming up soon. Good luck the rest of the way.
Thank you so much.
Yeah, thank you so much.
Thanks for watching. Don't forget to like, subscribe, and click the bell to stay up to date on future fun videos. Founded by First alumni, FRC Tees understands what teams need. High-quality apparel fast. From t-shirts to jackets and more, with a free 14-day turnaround and faster options available, you can join 200-plus teams who are already saving. Get a free quote by scanning the QR code or going to frctees.com. For over 100 years, Kettering University has offered a better education because from day one, that education has been built on hands-on, co-op learning. Kettering's impressive alumni network includes founders, presidents, CEOs, and frontrunners who have a reputation for transforming industries with their resolute leadership. Apply today at kettering.edu/first.